Hi everyone, this is Zhichao Xu, currently a PhD student at University of Utah. Today I will help you to walk through our paper, E-commerce recommendation with weighted expected utility. This is a joint work with Yi Han, advised by Professor Yongfeng Zhang and Professor Qingyang Ai. So let's start. First, I will introduce our problem setting. The most significant difference between shopping at retail stores and e-commerce is that in e-commerce, users cannot see or try the products before making purchase decisions. Often, important information is neglected. Second, I will introduce some background knowledge. The outcomes of online shopping can be highly uncertain, and users usually make decisions based on their perceived utilities of candidate products, using the information displayed at the website, including image, video, historical ratings or reviews, etc. So if we can understand how different individuals estimate the utilities of candidate items, we can conduct better recommendations. This leads to the utility theory. This is a term used in economics. Basically, the utility theory is the statistical expectations of the individual's valuations of different outcomes. Also, there exist psychology biases in decision-making procedure. Often, the outcome of a decision can be divided to gain or loss. For the potential risk, different people hold different views. Let's consider this example. The two most recent movies, their mean ratings and the median ratings are the same, but clearly the rating distributions are quite different. A risk appetite user probably will choose Mulan, hoping to get much utility out of it, while a more conservative user probably won't take any risk and choose to watch the other one. Also, the estimation of probability is actually biased. In the case of lottery or gambling, the individuals will systematically overestimate the probability that they get benefit, even if the chance is very little. So now let's talk about the model. We make several major assumptions. First, we assume that each individual user will estimate the expected utilities of the candidate items and choose among the top ones. We interpret the utility as a sense of satisfaction, which can be reflected by the rating given to the item after the transaction. Based on the previous conclusions given by the economic researchers, most users are risk appetite in terms of gains and risk averse in terms of loss. And they will systematically underestimate the events with a large probability and overestimate the events with small probability. We will use real-world e-commerce datasets to validate their thoughts. So let's talk about the model. Our model mainly consists of two major parts. The first is a utility module. The second is a probability weight function module. Then we multiply them together to estimate the expected utility of a candidate item. This is a summary of notations will be used in the following slides. The utility module mainly deals with the estimation of utilities. We formulate the utility function using a hyperbolic tangent so that the shape is convex for loss and concave for gain. We also use RFIG and BitIG to adjust the shape. The probability weight function module mainly deals with the biased estimation of probability. We used two different functions originally proposed by the economic researchers. To improve, we also add a third scale parameter to control the shape of the curve, as well as speed up the model convergence. We reparameterize the model parameters using collaborative filtering with latent factorization. For the training of our model, we optimize the parameters using a pairwise loss. Let's talk about the experimental settings. We compare our model with both classical recommendation models and economic recommendation models. We also compare the performance with neural collaborative filtering, which is state-of-the-art deep learning-based recommendation models. We used 3 categories of the Amazon review dataset. To evaluate the performance, we use precision, recall, F1 score, and NDCG. So this is a table of performance in one of the datasets we used. We can see that our proposed method shows improvement over all the baselines. Also, we can see that the scale parameter we added also help with performance, as well as speed up the convergence of the parameters. In this figure, we show the average user's probability weight function. We can see that the average user is actually biased in the estimation of probabilities. In this page, we show the distribution of RFIG and beta-IG for all the users, which the RFIG and beta-IG are will control the estimation of utility. We can see the normal distributions mu is actually less than 0. So most users are risk averse in terms of gains, in terms of loss, and risk appetite in terms of gains. This is the same as the conclusion of the previous economic researchers. To conclude, our contributions are: we introduced the concept of expected utility in terms of satisfaction. We propose a personalized recommendation model under e-commerce settings. Our model is capable of learning the information of personalized risk preference and psychology bias. So if you have any questions about the paper, you can contact me by email or post threads under the GitHub page. Thank you for your time.